So welcome to the video lecture series on principles of compiler design. In today's video lecture, we will be learning about issues in the design of code generation. So there are 6 major issues which is connected to this code generation. The first one is input to the code generation. The next is target program. The third is memory management. Fourth is actually instruction selection. Fifth goes for register allocation, and the sixth is called as evaluation order. Okay. Now, what is the kind of problem with input to your code generation? So first we have to decide what kind of input we are going to give to the code generator. Okay. Generally we give input in the form of intermediate language, but intermediate language itself has different versions. The first version is we have a postfix notation. So what is a postfix notation? We have an expression and operands will be on the front and the operator will be at the end. For instance, we have an expression called as x plus y. So the operator is actually plus here, x and y are actually called as operands. Okay, so when we try to convert that into a postfix notation, it will be xy plus. So first we have to decide what kind of input we are going to give, whether we are going to give it as a postfix notation or whether we are going to give a 3 address code. So when we talk about 3 address code, again this 3 address code have 3 different strategies or 3 different versions. One is actually a quadruple. Quadruple will have 4 fields spanning from operator, argument 1, argument 2 and result. We have 4 parameters. When we talk about triples, we have 3 arguments there. One is operator, another is argument 1 and argument 2. So argument 1 and argument 2 actually it's the operands which we use in an expression. And the third one is indirect triples. This is similar to triples, but the triples we have an additional parameter here. We have a pointer parameter. Pointer is used to represent a triple, which is used to point out a triple. So that is called as indirect triple. Now, the third input to code generation is actually a directed acyclic graph, or shortly called as DAG, or otherwise it is called as a syntax tree. So, these are the 3 major issues. First issue is whether we have to decide which kind of input we are going to give to the code generation. So, that's called as input to a code generator. Now, moving to the second point, what is meant by a target program? Okay, target program is actually the final output what we obtain from a code generation. Might be a machine code or an assembly code, and again we have 3 major versions in this. The first version is whether the target program is going to be an obsolete machine code. So what is meant by an obsolete machine code? When we talk about obsolete machine code, the memory is actually fixed in a RAM. Okay, so the code will be executed in the fixed portion of the RAM. Of course, you know that whenever we want to execute a code, definitely that code has to be loaded inside RAM. Okay, so it will be loaded in a fixed storage location. So that kind of code is called as absolute machine code. And the next is called as a relocatable machine code. Okay, this is not actually in contrast to absolute machine code. The memory is not fixed here. The memory keeps on varying. In short, what will happen here is it will generate an offset value, and through that offset it will generate an effective address. So this effective address is the place where this relocatable machine code will get executed. And why we are using this relocatable machine code? For example, when we try to run an program, normally libraries are required to run a program. For instance, we want to run a C program. We will be using #std include stdio.h. So that is a header file. It has so many libraries for printf, scanf and all. Now, all this, when we want to run our C program, all this library has to be linked together, and then this files has to be converted to an object file, and finally this object file has to be loaded using a loader inside the RAM. Okay, so such kind of code cannot be executed in a single portion. It has to be executed in chunks, or it has to be executed in stages. So all these multiple programs will be connected together, and finally object program will be generated, and then it will get stored in it will get loaded in a RAM. So such kind of code is called as relocatable machine code. So here the memory is not fixed, an effective address will be generated using an offset. Okay. Now the third one is called as assembly language program. Assembly language program is actually, we are accustomed to that. Now if we are writing the language in the form of mnemonics, then that is called as assembly language program. Say for instance, MOVE will be written as MOV, okay, just a short form of move, and addition will be written as add, subtraction will be written as sub, multiplication will be written as MUL. So anything for majority of the operations will be written in the form of short form. Okay, short form, we are writing the code in short form, then that is called as mnemonics. Now moving to the fourth major issue. Fourth major issue is called as memory management. Okay. Now what is this memory management? Why we want to learn this? For instance, when we run our program, we will be using so many variables or so many identifiers in our program, isn't it? So now all these identifiers are getting stored in a symbol table. Okay, so that's why using symbol table data structure, we will be keeping track of what is the status of that identifiers or variables throughout our program. Okay, now this programs or this identifiers actually require a memory location. Okay, that has to be allocated by the system, or that has to be allocated by the operating system. So mapping of these variables or mapping of the symbols to a runtime memory is actually done by memory management. So that is the role of memory management. So whatever variables we are using over there, whatever identifiers we are using over there, that has to be allocated a memory inside our system. So that is actually taken care by memory management. So this is the major issue connected with code generation. And the next one is instruction selection. So what is instruction selection? So you know that we will be writing the programs in high level language. So for example, C, Java, Python, whatever language you are writing, that is actually called as a high level language. Okay, but computers cannot understand such kind of high level languages. So it can understand only a low level instruction. So we have to replace this high level instructions with the help of low level instructions. For that we need a specific set of instructions which is accepted by a processor, and such kind of instructions are called as such kind of using instructions is called as instruction selection. For instance, in this case I am having a high level statement called as x is equal to y plus z. Okay, now this is a high level statement where the result of the summation of y and z is getting stored in x. But computer, or normally a computer cannot understand this instruction. So this has to be replaced by low level instructions. So what I am trying to do is I write a assembly language code. First I actually push value of y inside register R0. So MOV y comma R0, which stores the value of y to R0. The next step what I am doing here is I add Z with R0. Z with R0. Z is the second operand. So I try to add that to R0. So finally the result will be getting stored in R0. So at the end, what we have to do is we have to take this result and store it in X here. Okay, so result will be available in R0. So I try to move R0 to X. So that is done with the help of this instruction called as MOV R0 comma X. Okay. So one high level instruction is actually replaced by 3 low level instructions here, but these three low level instructions are only understood by our computer system. So this is called as instruction selection. Okay, this kind of using an instruction to replace high level instructions is called as instruction selection. The next important thing is called as register allocation. You know that register is actually a memory location which is available inside the processor, and that is a scarce resource, very precious resource, and that too it is limited. It is a limited resource, so it has to be used efficiently. So we have to ensure whether the register is already available or not. If it is available, then that has to be allocated for using inside our program. That has to be used by our low level instruction. So this kind of process is called as allocation of register. The last one is called as order of evaluation. For anything, if we want to perform an efficient operation, then order of evaluation of an instruction is very important. So while we try to evaluate an order of instruction, we should actually eliminate these repetitive statements or redundant statements. So redundant statements or redundant code should not be there. Such kind of statements should be getting eliminated, and the order of evaluation of the instruction is actually plays a significant role in execution of the instruction. So that's about evaluation of the instructions. Also, these are the 6 major issues connected with the code generation. So thanks for watching the video. Have a good day.